Okay, so here's the example I want us to look at. Another example using the concept of boiling point, or in this case, freezing point depression. Um, so the question is asking for the molar mass of a solute. If 9.00 grams in 250 grams of water freezes at 0.372 degrees Celsius. Okay, so basically, let me just highlight the important aspects of this question. So you're given the mass of the solute here. You're given the mass of the solvent here. You're given the freezing point, which is minus, here's a negative sign, minus 0.372 degrees Celsius. And of course, importantly, you're given the KB value for water, the boiling point. Um, Actually, you're going to need the freezing point value. So sorry about that. Let me go here, here. Okay, so the freezing point value is what you're going to need, which is 1.86. So let me go back to this right here. Whoops, scrolled up too much. So you're going to need here, KF for water equals to 1.86 degrees Celsius over M. All right? Okay, so first thing I would write down here is the equation for the freezing point depression. Delta TF is equal to minus KF times the molality. All right? So what I would do is rearrange this to get the molality. Molality is equal to delta TF over minus KF. All right? So according to the question, delta TF is minus 0.372 degrees Celsius divided by minus KF, which is 1.86 degrees Celsius over M. So let me do this on my trusty cheap calculator here. 0.372 divided by 1.86. Okay, so according to my calculations, this works out to be equal to, and I have to write this to the correct number of sig figs, 0.200 M. All right? So that would be the molality. Now remember, molality by definition is equal to the moles of solute over kilograms of solvent. So moles of solute divided by kilograms of solvent. All right? So to find the moles of solute, oops, that would be equal to the mass, the molality times the mass in kilograms of solvent. So what I have to do here is put the numbers in. The molality we calculated to be 0.200. Now the M unit here can be expressed as moles per kilogram, right? So let me just put a note here. M is the same thing as moles per kilogram, all right? So the reason why I do that is because you can see where the units will cancel out when I multiply by the kilograms of solvent. Now they gave you the mass of the solvent as 250 grams, which is equal to 0.25 kilograms. So the kilogram units will cancel out here and here, and you'll be left with the moles, which is 0.2 times 0.25, which it works out to be, again, you have to be careful about the sig figs. In this case, it's 2 sig figs, 0.050 moles. So once we do that, we can now calculate the molar mass. So the molar mass is equal to the kilograms, or I should say the grams of the solute, which is 9.00 grams, divided by 0.050 moles. So 9 divided by 0.05. And according to my calculations, this works out to be equal to, again, we have to round off to 2 sig figs. So this would be 180, and the units would be grams per mole. So that's basically how this problem is done. All right. So the next video, we'll be dealing with another colligative property known as the osmotic pressure. So until next time.